Okay, so question one. It's all about water reflecting off the side of a stationary boat, right? Okay, so we know the law of reflection, don't we? It's that the angle of incidence is equal to the angle of reflection. So straight away, I've got a way into the problem. But that's not what it asks us to do first. It asks us to draw the normal. Now, the normal, it tells you is where the waves meet the side of the boat, right? And we need to draw the normal perpendicular to the side of the boat, because that's what normal means. It means at right angles too. Okay, so you can see the angle between the dotted line and the side of the boat is 90 degrees, and that's going to get me 1 mark. Measure the angle of incidence of the water waves. Okay, if you measure that carefully with a protractor, okay, it's about 65 degrees. And you're allowed to be inaccurate by a degree. So there we go, 65 degrees. And why is that the angle of incidence? Because we always measure the angle between the ray, okay, and the normal. Some of you measured this angle down here. That's not correct. That's not the angle of incidence. All right. So whenever you measure an angle, always measure from the normal to the ray. Complete the diagram to show the wave fronts after they reflect off the side of the boat. Well, the first thing that I'm going to do is draw the direction of travel of the wave fronts. Okay, and how did I know where to draw that? Well, that's got to be 65 degrees as well. Why? Because I equals R when waves are getting reflected, right? But I'm not finished yet. Why? Because it asked me to draw the wave fronts, right? So I need to draw some of the wave fronts. Okay, and if you're doing it carefully, then the wavelength should be the same, and it should be the same as these wave fronts over here. All right. The final thing that I need to do is indicate the direction of travel, okay, by putting an arrow on there, right? Now that's perfect. Boat starts to move, creating its own waves on the surface of the water. Surface water waves are transverse, right? And what's the difference between transverse and longitudinal waves? Okay. Now it doesn't suggest drawing a diagram, but a diagram can really help here. Okay, and that's because, okay, for a transverse wave, we've got to get this idea, haven't we? Right? Now, lots of people said perpendicular, but that's not enough, because we haven't said what is perpendicular to what. Okay, and it's important that we get this idea of displacement of the wave, right? So just by labeling up my diagram, okay, I'm scoring this mark. Displacement of the wave, and then this is the flow of energy of the wave. Okay, there are other ways that you could score those marks by talking about oscillations and the direction of travel of the wave, but I think that is the most elegant way of doing it. So to put that into a sentence, if you wanted to write it out, transverse waves are when the displacement of a wave is perpendicular to the flow of energy of the wave. All right, and then of course for longitudinal waves, like a slinky spring, something like that. Okay, you can see that the displacement here, okay, that's the displacement, that's the flow of energy, and you can see that the displacement is parallel to the flow of energy for a longitudinal wave. Okay, this shows a boat moving towards an observer, right? So what are we seeing here? It's something called the Doppler effect. Okay, and let's try and unpack that in a bit more detail. You notice that when the boat's moving towards the observer, okay, that you can see that the wave fronts here, they're close together, right? So that means that the wavelength is decreased, okay, as you move towards the observer. But the velocity of the waves in the water stays the same. That's constant. Okay, so hopefully you can see where this is going. It's going to this formula here, right? So we've got V equals F lambda. if this number over here is constant and this number over here decreases, then the only way that that can happen is if this number here increases. So there we go. The frequency increases. Okay. Now careful, it's nothing to do with how far away the boat is from the observer. It's all to do with the direction that the boat is moving in, right? So when it's moving towards the observer, then the observer will observe an increased frequency. Once the boat's gone past the observer, of course, then we've got this, you know, this thing, right? If you imagine that the boat's over here now, okay, like that. Okay, then you get the opposite effect. But that's not what the question's asking you about, right? It's asking you about as it's moving towards the observer, right? It tells you that in the beginning of the question. Okay? All right, and that is the end of question 1. And I've just got to work out how to stop the video. How do I do that?